Hello friends, welcome back to my channel Maths by Samit Deshmukh. In this video, we are solving a remaining example from question number 4 of exercise 1.5. In the last video, we have completed first 5 examples, isn't it? So if you are new on my channel, subscribe the channel and hit the bell icon to get notification of every newly uploaded video. And if you think that these videos are helpful to you, so please share these videos with your friends also. In this question number 4, we are finding nth order derivative. Already the method of finding nth order derivative we have discussed in the last 5 examples. Same method we are applying here. And what we have seen, first find out first order derivative, second order derivative and third order derivative. Observing the values of first order, second order and third order derivative, we have to find out the value of nth order derivative. Means we have to find out in general form that nth order derivative can be written in which form. So let us begin with the next example, means example number 6. In this case, given function is y is equal to cos x. So we are differentiating it with respect to x. So to find out first order derivative, so dy upon dx is equal to, what is derivative of cos x will be equal to what? Minus sin x. Now again we are differentiating it with respect to x. So let us see what second order differentiation we will get. So derivative of dy by dx is d2y upon dx square. On this side minus, keep it as it is, and what is derivative of sin x will be equal to what? Cos x. In this way we have got second order derivative also. Now again we are differentiating it with respect to what? X. So we will get third order derivative, that is d3y upon dx raised to power 3 is equal to minus, keep it as it is, what is derivative of cos x will be equal to minus sin x, and minus into minus will become what? Plus sin x. Now observing the value of first order derivative, second order derivative and third order derivative, we have to find out nth order derivative. So in general form, nth order derivative can be written as, so we are finding the value of what? Nth order derivative. So here given example is in terms of what? Cos. That's why I am trying to convert every terms in terms of cos, and later on observing this value we will see how to find out the value of nth order derivative. Now observe here minus sin x. Can I say that it is the value of cos pi by 2 plus x according to allied angle formula? Yes, cos pi by 2 plus x will be equal to what? Minus sin x. We are applying here allied angle formula just simply to convert it in the form of what? In the form of cos. Now here already this value is in terms of cos. So just we are trying to replace this minus. Again here we are using allied angle formula. So we know that minus cos x is nothing but value of cos pi plus x. Pi plus x means which quadrant? Third quadrant. So here cos pi plus x will be equal to what? Minus cos x, and in the third quadrant value of cos is what? Negative. So in this way, applying allied angle formula, minus cos x we have converted, just we have tried to eliminate what? Minus, applying allied angle formula, isn't it? Now this sin x can I write it as cos 3 pi by 2 plus x? Yes, in the fourth quadrant. 3 pi by 2 plus x means fourth quadrant. Value of cos will be what? Positive, and 3 pi by 2 means cos will get converted into sin. So this formula is already you have studied in class 11th, isn't it? So now we are trying to represent them in the same form. So here in case of first order derivative, we can observe that coefficient of pi by 2 is what? 1. In case of third order derivative, coefficient of pi by 2 is what? 3. In case of third order derivative, coefficient of pi by 2 is 3. So but here pi by 2 is not there. So to arrange the term in this form, just see we are doing one adjustment. So pi plus x, keep it as it is. Simply I am dividing by 2, and as I am dividing by 2 I am multiplying here by 2. Now in case of second order derivative, now we can observe that coefficient of pi by 2 is what? 2 here. Means here easily we can observe that in first order derivative coefficient of pi by 2 is 1. In second order derivative, by doing adjustment, what adjustment we have done here, that coefficient of pi by 2 will be equal to 2. That pi we are able to replace it by 2 into pi by 2, means simply multiply by 2 and divided by 2, so that all the terms should be in the same form. And in case of third order derivative, easily we can observe that coefficient of pi by 2 will be what? 3, isn't it? So in nth order derivative, then what will be your answer? Cos, here coefficient of pi by 2 will be equal to n. Can I say that n? Yes, in first order derivative coefficient of pi by 2 is 1. In second order derivative coefficient of pi by 2 is 2. Here in third order derivative coefficient of pi by 2 is 3. Means definitely in nth order coefficient of pi by 2 will be equal to what? N. So in this way we have got the nth order derivative of given function. Now see, in the seventh example, given function is y is equal to sine ax plus b. So let us try to find out here first order derivative. So dy upon dx will be equals to, if you observe this function, is it in the form of sine f of x? Yes, its derivative will be equal to cos f of x. What is the value of f of x? Ax plus b into derivative of f of x, that is ax plus b. So which is equal to here cos ax plus b, keep it as it is, and just simply we are finding derivative of this equation, linear expression. So derivative of ax will be a and derivative of constant term is 0, means easily we can say that derivative of this whole term is a. So here a into cos ax plus b will be the first order derivative. Again we are differentiating it with respect to x. So let us differentiate it with respect to what? X, to find out second order derivative. d2y upon dx square will be equals to, here a is a constant term, keep it as it is, a is a constant term. Derivative of cos f of x will be equals to what? Minus sine f of x. What is the value of f of x? Ax plus b into derivative of f of x, and here we can observe that value of f of x is ax plus b, isn't it? Now here a into minus will be equal to minus a sine ax plus b, keep it as it is. Okay, so we have keep this term as it is, just simply a into minus will become what? Minus a. Now we are finding differentiation of this term, and we know we can easily say that its differentiation will be equal to a. So here its derivative will be equals to a. Later on we will try to convert all the terms in terms of sine applying allied angle formula, but first let us try to find out first order, second order and third order derivative. Now again we are differentiating it with respect to x, so let us differentiate it with respect to what? X. So derivative of d2y upon dx square is d3y upon dx cube, and on this side here minus a into a will be equals to what? Minus a square. Minus a square is a constant term, keep it as it is, and now we are finding derivative of this term which is in the form of sine f of x, so its derivative is cos f of x, means cos ax plus b into derivative of ax plus b, so which is equal to, keep this term as it is, minus a square cos ax plus b, keep it as it is, and here derivative of ax plus b will be equals to what? A. In this way we have got first order, third order, second order and third order derivative. Now we are trying to find out that nth order derivative. That nth order derivative in general form can be written as, isn't it? Now example is in terms of sine, that's why we are giving priority to convert all the terms in terms of what? Sine. Now here observe the first term very carefully. So here a is a constant term, keep it as it is. Now is it in the form of cos theta? Yes, cos theta according to allied angle formula, can I say that it can be replaced by sine pi by 2 plus theta? Theta is what here? Ax plus b, isn't it? Again observe here, what is the value of sine pi by 2 plus theta will be equal to cos theta according to allied angle formula, keep this a as it is, and value of sine pi by 2 plus theta is equal to cos theta, where theta is nothing but what here? Ax plus b. Hope you are getting it. Just simply we have tried to convert this in terms of what? Sine. Now here we can observe that coefficient of pi by 2 is 1. In case of second order derivative, let us check whether coefficient of pi by 2 will be 2 or not. In case not 2, we will try to do some adjustment to convert it in terms of 2. Okay, so which is equal to, so now here minus a into a will be equals to a square, will be equals to what? Sorry, a into a will be equals to a square, and keep this sign as it is, sin ax plus b as it is. Just simply now we are already, the term is in terms of sine, but we are trying to convert it in this form. सब तीनों differentiation के form same होने चाहिए, so that we are able to find out value of nth order derivative. Hope you are getting it. Now according to allied angle formula, so here sorry, minus, keep it as it is, because minus a into a is minus a square. Now try to understand minus sine theta sine theta, is it the value of sine pi plus theta? Sine pi plus theta. Theta is what here? Ax plus b. You are getting it? So now this minus sine theta is the value of sine pi plus theta. Sine pi plus theta, we know that according to allied angle formula will be minus a sine theta. So minus sine a sine theta just simply can be replaced by sine pi plus theta. Now here we are trying to convert it in terms of pi by 2. So that's why I am dividing by 2, and as I am dividing by 2 I am multiplying by 2. This is simple adjustment which we are doing here. Again here observe that. So here minus, keep it as it is, a into a square will be a cube. Keep this term as it is. What is this term? Minus cos ax plus b. Okay, just simply a into a square will become a cube, and keep the remaining part minus cos ax plus b as it is. So which is equal to a cube as it is. Now this expression is in the form of minus cos theta. We are trying to convert it in terms of sine applying allied angle formula. और यहाँ पे पाई बाय 2 का कोएफिशिएंट 1 है, सेकेंड ऑर्डर डेरिवेटिव में 2 है, तो यहाँ पे 3 आ सकता है क्या, चेक करके देखते हैं. So here can I say that this minus cos theta is the value of sine 3 pi by 2 plus theta. Theta is what here? Ax plus b, isn't it? Again observe here, according to allied angle formula, sine 3 pi by 2 plus theta is minus cos theta. Yes, so minus cos theta can be converted in terms of sine. Now all the first order, second order and third order means required differentiations are known to us, which will help us to find out the value of nth order derivative. Now observe the first term. In the first term means in first order derivative, first term is a, power of a is 1. In second order derivative, power of a is 2. In third order derivative, power of a is 3. Means can I say that in nth order derivative, power of a will be n. Okay, now first term is known to us. Now observe the second term. Second term, in first order derivative, here all the terms are in the form of sine, but in the first order derivative, coefficient of pi by 2 is 1. In second order derivative, coefficient of pi by 2 is 2. In third order derivative, coefficient of pi by 2 is 3. So here we can say that coefficient of pi by 2 will be n in case of what? Nth order derivative. N pi by 2 plus ax plus b. In this way, observing first order, second order and third order derivative, we have got our required value, means nth order derivative. Now observe the example number 8. In this case again the function is in the form of y is equal to cos x, means in sixth example also function is in the same form. Only x is replaced by what? F of x, means exactly same method we have to apply here, which we have applied in which example? Example number 6. Okay, so let us try to find out first order derivative. So we are differentiating it with respect to x. So to find out value of first order derivative, so now here function is in the form of cos f of x. What is the derivative of cos f of x? Will be minus sine f of x. What is f of x? 3 minus 2x into derivative of f of x, where f of x is nothing but 3 minus 2x, isn't it? So which is equal to, now here differentiation of this term, is it equal to minus 2? Yes, so keep this term as it is, minus sine 3 minus 2x, keep it as it is, and derivative of this term will be equals to minus 2. Just simply I am writing minus 2 here, minus 2 into minus sine 3 minus 2x. Okay, here I am able to simplify it also. Minus into minus will become what? Plus. But I am not simplifying it. To get our required result, it is important to keep minus 2 as it is, because we are trying to arrange every term in the same form. और हर एक टर्म में हमें इसका डिफरेंशिएशन फाइंड ही करना है. तो यहाँ पे minus 2 मिला, तो अगेन सेकंड ऑर्डर डेरिवेटिव में इसका डिफरेंशिएशन minus 2 मिलेगा. minus 2 into minus 2 here will become square of minus 2. In the next term it will become cube of minus 2. That's why we are not disturbing to term of minus 2, means we are not simplifying it. Keep this minus 2 as it is, isn't it? And here easily we can observe that in the first order derivative its power is 1. It means definitely in second order derivative its power will become what? 2. So observe here, now we are again differentiating it to find out its second order derivative. So its derivative, second order derivative is d2y upon dx square. Here minus 2 is a constant term, keep it as it is, minus 2 as it is, and here minus as it is. Now derivative of sine f of x will be cos f of x. What is f of x? 3 minus 2x into derivative of f of x. What is f of x here? 3 minus 2x, isn't it? Now keep this minus 2 as it is, so which is equal to minus 2 as it is, and here minus cos 3 minus 2x also as it is, and simply here we can say that differentiation of this whole term will be equals to what? Minus 2. Now minus 2 into minus 2 will become what? Square of minus 2, and here minus cos 3 minus 2x, keep it as it is. Okay, later on we will simplify it, means we are trying to convert every term in terms of cos. तो यहाँ पे sin है, sin को cos में convert करेंगे. Again here we will try to eliminate minus also. सब term sin में convert cos में convert करने की कोशिश करेंगे, because given example is in terms of what? Cos. Now again differentiate it to find out third order derivative. So differentiate it with respect to x. So its differentiation is d3y upon dx cube. On this side keep minus 2 square as it is, this minus also as it is. Now we are finding derivative of cos f of x. What will be its derivative? Minus sin f of x, where f of x 3 minus 2x, isn't it? Into derivative of f of x, where f of x is nothing but 3 minus 2x, isn't it? So which is equal to, now keep this square of minus 2 as it is, square of minus 2 as it is. Again here minus into minus will become plus sine 3 minus 2x, and derivative of this term will be equals to minus 2. Now minus 2 into square of minus 2 will be equal to cube of minus 2 into sine 3 minus 2x, keep it as it is. Minus 2 into minus square of minus 2 is cube of minus 2, isn't it? In this way we have got third order derivative. Observing the value of first order, second order and third order derivative, we are trying to find out nth order derivative in general form. So we are trying to find out what? Value of nth order derivative. So here we are trying to convert it in terms of cos, because example is in terms of cos. We are not disturbing to first term. Keep minus 2 as it is. Minus sine theta, can I write it as cos pi by 2 plus theta? Theta is 3 minus 2x here. Minus sine theta can be replaced by cos pi by 2 plus theta according to allied angle formula. So in this way we have converted this expression in terms of what? Cos. Now here already expression is in terms of cos, just we are trying to eliminate what? Minus. So here keep this minus 2 whole bracket square as it is. We can say that minus cos theta is nothing but value of cos pi plus theta. Pi plus theta, theta is what? 3 minus 2x. Try to understand. Again according to allied angle formula, value of cos pi plus theta will be minus cos theta. But here term is in the, this term is in the form of pi by 2. So here also we are trying to convert it in terms of pi by 2, and to convert it in terms of pi by 2 I am dividing by 2, that's why I am multiplying by 2. So now we can observe that in first order derivative coefficient of pi by 2 is 1, and in second order derivative coefficient of pi by 2 is what? 2. In the third order derivative, let us check whether coefficient of pi by 2 will become 3 or not. Okay, so here keep this term as it is. Minus 2 cube, keep it as it is, and sine theta, can I replace it by cos 3 pi by 2 plus theta? Theta is what here? 3 minus 2x. Yes, we know that value of cos 3 pi by 2 plus theta will be equal to sine theta. Means sine theta can be replaced by cos 3 pi by 2 plus theta. Theta is here 3 minus 2x according to allied angle formula. Now observing this value, means value of first order, second order and third order derivative, we are trying to find out value of nth order derivative. In every case observe that first term is minus 2 minus 2 minus 2. In first order derivative its power is 1, in second order derivative its power is 2, in third order derivative power of minus 2 is 3. So we can say that in nth order derivative power of minus 2 will be n. Again here we can observe that all the terms, second term is in terms of cos, so means here also definitely we will get cos. But here coefficient of pi by 2 is 1, here pi by 2 is 2, and in third order derivative coefficient of pi by 2 is 3, means in nth order derivative we can say that coefficient of pi by 2 will be n. keep remaining term is same in every case, that is plus 3 minus 2x plus 3 minus 2x plus 3 minus 2x, isn't it? So in this way we have got our required value, means nth order derivative. Now see the example number 9th. In this case, given function is y is equal to log of 2x plus 3. Now we are differentiating it with respect to x. So dy upon dx is equal to, so what is the derivative of log f of x will be 1 upon f of x, where f of x is 2x plus 3 into derivative of f of x, means derivative of 2x plus 3. So which is equal to, keep this term 1 upon 2x plus 3 as it is, and derivative of this whole term will be equal to 2. Later on we will simplify it to arrange the term in the general form, means we will arrange it in this form such that observing this term we are easily able to conclude what will be the value of nth order derivative. First we are finding second order derivative. So first differentiate it with respect to x. So now we will get the value of d2y upon dx square. So here it is in the form of 1 upon f of x. 2 is a constant term. 2, keep it as it is. 1 upon f of x. What is differentiation of 1 upon f of x? That will be minus 1 upon square of f of x. Square of f of x. Keep this 2 as it is. 2 as it is into derivative of f of x. What is f of x here? 2x plus 3. Again observe here, this function is in the form of 1 upon f of x. So its differentiation is minus 1 upon square of f of x into derivative of f of x. These two, keep it as it is, isn't it? Now let us simplify it. So which is equal to minus 1 upon 2x plus 3 minus 1 upon 2x plus 3 raised to power 2, keep it as it is, and here also 2 as it is. And what is differentiation of this term will be equal to 2. In the next step we will write down 2 into 2 will be equals to what? 2 square. But before that let us try to find out its differentiation, means third order derivative. Okay, first better way, write down it in the form of that 2 into 2 can be replaced by what? 4. So here we will get minus 1 upon 2x plus 3 raised to power 2 into 2 square, isn't it? So here easily we can observe that in the first order derivative power of 2 is 1, in second order derivative power of 2 is 2, in the third order derivative let us check whether such type of term exists which can be replaced by 2 raised to power 3 or not. Okay, so now we are differentiating it with respect to x. So differentiate with respect to x. So to find out third order derivative, so which is equal to, now I am finding differentiation of this term, minus 1, keep it as it is. Minus 1 is a constant term, keep it as it is. Now remaining term is in the form of 1 upon f of x. What is differentiation of 1 upon f of x? That will be minus 1 upon square of f of x. What is f of x? 2x plus 3 raised to power 2. If we are taking it square we will get 2x plus 3 raised to power 4 into derivative of this f of x. 1 upon f of x, ये पूरा term f of x है. So into derivative of f of x, here observe f of x is 2x plus 3 raised to power 2, and keep that last term 2 raised to power 2 as it is. This constant we are not disturbing, we are keeping it as it is. So which is equal to, now here minus 1 into minus 1 will become plus 1, and in the denominator we will get 2x plus 3 raised to power 4. Now here we are finding its differentiation. So first take power of f of x as an coefficient, then decrease power of this f of x, means 2x plus 3 by 1, decrease power by 1. If we are decreasing power by 1, then new power will become 1 because the adjacent power is 2. So if we are decreasing it by 1, so new power will be 1 into derivative of this term, means into derivative of 2x plus 3, and lastly 2 raised to power 2, keep it as it is. 2 raised to power 2, we are not disturbing to it. Okay, so which is equals to, now observe here what result we are getting. So first write down 2 into 1 will be equals to 2. Again 2x plus 3, and one term of 2x plus 3 from denominator will get cancelled. So here its power will decrease by 1. So new power will be equals to, what will the new power then? 3, isn't it? Now we are finding differentiation of this term. What will be its differentiation? 2, and last term 2 square, keep it as it is. Its differentiation will be equals to 2, and lastly 2 square, keep it as it is. In this way we have got first order, second order and third order derivative. Observing this value we have to tell what will be the value of nth order derivative. So let us try to find out value of nth order derivative here, observing the values of first order, second order, third order derivative. First we will observe the signs. In first order derivative result is positive, in the second order derivative result is negative, in the third order derivative again the result is positive, means पहले positive है बाद में negative है फिर positive है. So here I am just trying to arrange these signs के लिए यहाँ पे positive है, so can I replace it by -1 raised to power 0, because any number raised to power 0 is what, 1. तो यहाँ पे क्या मिलेगा, -1 raised to power, -1 raised to power, यहाँ पे 0 लिया तो यहाँ पे 1 अगर लेता हूँ मैं, so what is the value of -1 raised to power 1 is -1, means we are getting negative value, into 1 upon 2x plus 3 raised to power 2. I am not disturbing to this term क्योंकि ऑलरेडी यहाँ पे 2 का पावर 1 है और यहाँ पे 2 का पावर 2 है, so we are not disturbing to that term. So here keep this term as it is, 1 upon 2x plus 3 into 2. Okay. Now observe the last term. Last term में यहाँ पे 2 ये दिस टर्म इज पॉजिटिव. पहले तो साइंस के बारे में सोच रहे हम, यहाँ पे 0 लिया तो पॉजिटिव था, -1 का पावर 0, सो वी नो दैट एनी नंबर रेज़्ड टू पावर 0 इज 1. सो हियर पावर इज 1, सो वी कैन से दैट इट्स वैल्यू इज नेगेटिव. अगर यहाँ पे मैं पावर -1 का पावर 2 में लेता हूँ, जस्ट आई एम ट्राइंग टू अरेंज द टर्म इन द सेम फॉर्म. सो पॉजिटिव है तो उसे हम -1 रेज़्ड टू पावर 2 ले सकते हैं, isn't it? Because we know that square of -1 is +1, not necessarily +1. Getting it? But this shows that here value is positive, this shows that here value is negative, this shows that here value is what, positive. Okay, now this 2 into 2 square will be equals to 2 cube. यहाँ पे 2 का पावर 2 था, यहाँ पे 1 था, यहाँ पे 3 मिला, फिर भी यहाँ पे एक टर्म और है. कौन सी टर्म और, ये दोनों का मल्टीप्लिकेशन तो हो गया 2 क्यूब. व्हाट इज मिसिंग, 2. तो उस 2 के बारे में बाद में सोचेंगे हम. 2x plus 3 रेज़्ड टू पावर 3 एज इट इज. चलो ये दोनों का प्रोडक्ट यहाँ पे 2 क्यूब आ गया, यहाँ पे बचा क्या है, 2. Now can I say that 2 is the value of 2 factorial? Yes, 2 is the value of 2 factorial. 2 factorial, can I write it as 3 minus 1 factorial? 3 minus 1 means what, 2 factorial. 2 factorial means product of first two natural number, means 1 into 2 is 2. So this 2 can I write it as 3 minus 1 factorial. अभी यहाँ पे देखो 1 है, 1 means what, value of 1 factorial. 1 factorial, can I write it as 2 minus 1 factorial? Yes, 2 minus 1 factorial is 1 factorial, and 1 factorial is equal to 1. And here also 1 is there. 1 can I write it as 0 factorial, and 0 factorial can I write it as 1 minus 1 factorial. 1 minus 1 is 0 and 0 factorial is 1. यहाँ पे 1 था, 1 को हमने just replace किया, 1 minus 1 factorial. Okay, चलो अभी ये term observe करो बेटा. First order डेरिवेटिव में यहाँ पे क्या है, हमें 1 minus 1 factorial. सेकेंड ऑर्डर डेरिवेटिव में 2 minus 1 factorial. थर्ड ऑर्डर डेरिवेटिव में 3 minus 1 factorial. तो nth ऑर्डर डेरिवेटिव में n minus 1 factorial मिलेगा. Just to find out the value of nth order derivative, we are arranging this term, we are trying to arrange this term in the same form. Differentiation तो यहीं पे मिल चुका है हमें. Just we are arranging this term in such a way that easily we are able to conclude what will the value of nth order derivative. Okay, चलो अभी देखो यहाँ पे फर्स्ट ऑर्डर डेरिवेटिव में -1 का पावर 0 था, सेकंड में 1 था, थर्ड ऑर्डर डेरिवेटिव में 2 था, थर्ड में 2 था, यानी 1 से कम था. तो nth ऑर्डर डेरिवेटिव में -1 का पावर n-1 होगा, 1 से कम होगा. यहाँ पे थर्ड ऑर्डर डेरिवेटिव में 3 minus 1 means 2. फर्स्ट ऑर्डर डेरिवेटिव, सेकेंड ऑर्डर डेरिवेटिव में 1 मीन्स व्हाट, 2 minus 1. तो nth ऑर्डर डेरिवेटिव में क्या होगा, n minus 1. Okay, so चलो ये तो टर्म मिल गए हमें. Now we will observe this factorial. In the first order derivative, what we are getting, 1 minus 1 factorial. In the second order derivative, we are getting 2 minus 1 factorial. In the third order derivative, we are getting 3 minus 1 factorial. So in nth order derivative, can I say that we will get n minus 1 factorial? Okay, now observe the next term. In the first order derivative, power of 2 is 1. In the second order derivative, power of 2 is 2. In the third order derivative, power of 2 is 3. So in nth order derivative, derivative, we can say that power of 2 is n. Observe the denominator very carefully. In the first order derivative, power of 2x plus 3 is 1. In second order derivative, power of 2x plus 3 is 2. In the third order derivative, power of 2x plus 3 is 3. So we can say that in nth order derivative, power of 2x plus 3 will be n. In this way we have got the value of nth order derivative. आपको ये एडजस्टमेंट करने के लिए थोड़ी प्रैक्टिस करने की ज़रूरत है. एक दो एग्जाम्पल में अगर आपने अच्छी तरीके से प्रैक्टिस की, इजीली यू आर एबल टू डू दिस एडजस्टमेंट. Now see in the 10th example, what is the given function? Y is equal to 1 upon 3x minus 5. So again, to find out nth order derivative, first we are differentiating it to find out first order derivative. So it is in the form of 1 upon f of x. We know that differentiation of 1 upon f of x is minus 1 upon square of f of x, means 3x minus 5 whole bracket square into derivative of f of x. क्या है यहाँ पे f of x? 3x minus 5. 3x minus 5. So which is equal to, keep this first term as it is because nothing is there to simplify, so keep it as it is, minus 1 upon 3x minus 5 whole bracket square as it is. Now simply we are finding its differentiation. Easily we can observe that here derivative of this term will be equal to 3. So into 3. Later on we will simplify it. Adjust and keep it as it is. Okay. Now again differentiate it with respect to x. So differentiate it with respect to x. So we will get the value of second order derivative, means d2y upon dx square is equals to. Now observe that here it is in the form of 1 upon f of x. Keep this minus as it is. Minus as it is. Now it is in the form of 1 upon f of x. What is the derivative of 1 upon f of x? This whole term is f of x, and we know that derivative of 1 upon f of x is minus 1 upon square of f of x, means square of 3x minus 5 whole bracket square, means can I say that we will get raised to power 4. This is f of x, and if you are taking its square, its power will become what? 4 into derivative of f of x. और ये 3 as it is, 3 को बाद में देखेंगे, into derivative of f of x. f of x is what? 3x minus 5 raised to power 2, isn't it? और ये 3 as it is रखेंगे, 3 as it is. So which is equal to, now here minus into minus 1 will become what? Plus 1. So 1 in the denominator, 3x minus 5 raised to power 4 also as it is. Now we are finding its differentiation. Observe its differentiation. First take the power of f of x, because it is in the form of f of x raised to power n. So first take power of f of x as an coefficient, means 2 we have taken as an coefficient, then decrease its power by 1, means 3x minus 5 raised to power 1 into derivative of this f of x, into derivative of f of x, means derivative of 3x minus 5, and lastly keep this constant term 3 as it is. We are not disturbed to this 3 को जैसे के वैसे रखेंगे हम. So now observe here what we are getting, so which is equal to, here 1 into 2 will be equals to 2. This term and one term from the denominator will get cancelled. So here we will get 3x minus 5 raised to power 3. Again observe 3x minus 5 and one term of 3x minus 5 from denominator will get cancelled. So here power will become 3. Now we are finding its differentiation. Its differentiation is 3 into 3, keep it as it is. Okay, 3 into 3, keep it as it is. In the next step we will replace 3 into 3 by 3 square, but in the next step we will replace it. Again we are differentiating it with respect to x to find out third order derivative, and observing the value of first, second and third order derivative, we will try to find out the value of nth order derivative. So here third order derivative we are finding observing this term. 2 is a constant term, keep it as it is. 2, keep it as it is. Now we are finding its differentiation. It is in the form of 1 upon f of x. What is derivative of 1 upon f of x? That will be minus 1 upon square of this f of x. चलो ये f of x का square क्या मिलेगा हमें? f of x का स्क्वायर, ये पूरे टर्म का स्क्वायर क्या हो जाएगा? 3x minus 5 raised to power 6. If we are taking its square, 2 into 3 will become what? 6 into derivative of f of x, means derivative of this term. So into derivative of 3x minus 5 whole bracket cube, and here 3 into 3 will become 3 square. Keep this 3 square as it is. Okay, so which is equals to, here first write down minus 1, okay, then write down 2, then write down what? 2. Now in the denominator keep this term as it is. 3x minus 5 raised to power 6 as it is. Now we have to find out its differentiation. While finding differentiation, we are observing that term is in the form of which standard formula. So here easily we can observe that this term is in the form of f of x raised to power 3. So first take the power of f of x as an coefficient. So means take 3 as an coefficient, decrease its power by 1. So 3x minus 5 raised to power. What will the new power if we are decreasing power by 1? So new power will be 2. And keep this 3 square as it is. 3 square, keep it as it is. Sorry, into derivative of f of x. I have forget to write down derivative of f of x. Again observe, first take power of f of x as coefficient, decrease power by 1, then derivative of f of x means derivative of 3x minus 5. Derivative of 3x minus 5 and keep this 3 square as it is. 3 square as it is, isn't it? Okay, well, now let us simplify it. Let us simplify it. So now we can observe that this minus 1, keep the minus 1 as it is, minus 1 as it is. Again this 3 into 2, can I write it as 6? In the denominator these two terms will get cancelled. ये दो टर्म अगर कैंसिल हो गए, इसमें स्क्वायर और यहाँ का स्क्वायर अगर कैंसिल हो गया तो what will the new power of 3x minus 5? Is it 4? Again observe, 3x minus 5 raised to power 2 and here 3x minus 5 raised to power 2 will get cancelled. So new power will be here 4. Now derivative of this term is 3, derivative of this term is 3 and keep this 3 square as it is. So differentiation is completed now. Only we have to arrange the term so that easily we are able to find out value of nth order derivative. So therefore in general the value of nth order derivative can be written as, so nth order derivative will be equals to, okay, now here we can observe that minus is there, mean negative sign. In the second case positive, again negative. तो पहले साइन के बारे में सोचते हैं. Negative means can I say that it can be written as minus 1 raised to power 1? Yes. Here positive means can I write it as minus 1 raised to power 2 because minus 1 raised to power 2 is what? प्लस 1. तो यहाँ पे पॉजिटिव है तो इसे माइनस 1 रेज़ टू पावर 2 लिख दो. यहाँ पे अगेन निगेटिव है तो उसे क्या लिख सकते हैं हम? माइनस 1 रेज़ टू पावर 3. Just we observe the power. In the first order derivative, we have arranged what? 1 as a power of minus 1. In second order 2, in the second order 3. And it satisfies this condition. Minus 1 raised to power 3 is what? Minus 1. Okay? चलो अब ये लास्ट टर्म देखते हैं. यहाँ पे यहाँ बीच में की टर्म मुझे और लिखने की है, बाद में लिखूंगा मैं इसे. सो हियर पावर ऑफ 3 इज 1. अगेन हियर वी कैन ऑब्जर्व दैट पावर ऑफ 3 into 3 will become what? 3 square. Again in the denominator we are not disturbing to denominator keep it as it is. That is nothing but 3x minus 1 raised to power 3. Okay, and here denominator is 3x minus 5 raised to power 4. चलो डिनोमिनेटर के बारे में बाद में सोचेंगे. पहले तो क्या किया हमने? -1 को सिंप्लीफाई किया. अब ये 3 into 3 square will become what? 3 cube. यहाँ पे हमें 3 cube मिल गया. ओके, एंड हियर व्हाट वी हैव गॉट? -1 रेज़ टू पावर 3. बीच में की टर्म के बारे में बाद में सोचेंगे. और डिनोमिनेटर में 3x minus 4 का पावर क्या है? -5 का पावर क्या है? 4 को कैसे लिखना है ये भी बाद में देखेंगे. ओके, नाउ ऑब्जर्व हियर वी आर गेटिंग 2. Can I say that it is the value of 2 factorial? Yes, 2 is the value of 2 factorial. 2 factorial means 2 into 1. 2 into 1 is 2. Means this 2 can be written as 2 factorial. और यहाँ पे कुछ नहीं बोले तो 1 है. 1 को हम 1 factorial लिख सकते हैं. 1 can be replaced by 1 factorial. In the same way, here 6 can be replaced by 3 factorial. Yes, 6 can be replaced by 3 factorial because 3 factorial means 3 into 2 into 1 means product of first 3 natural number. So its value is 6. चलो ये 6 को भी simplify किया. अभी फर्स्ट ऑर्डर डेरिवेटिव में क्या है हमारा? पावर ऑफ 3x minus 5 is 2. So can I write this 3x minus 5 as this power 2 as 1 plus 1? Isn't it? Means in first order derivative, what is the power of 3x minus 5? It's 1 plus 1. Now in the second order derivative, here we have got cube. Can I write it as 2 plus 1? Means in the second order derivative, power of 3x minus 5, here minus 5 is there, 3x minus 5 is 2 plus 1. In the third order derivative, what is the power of 3x minus 5? 4 can I write it as 3 plus 1? चलो अभी यहाँ पे हम easily observe कर सकते हैं कि यहाँ पे power first order में 1 plus 1 है, second order derivative में 2 plus 1 है, third order derivative में power 3 plus 1 है, तो nth order derivative में क्या होगा? n plus 1. Isn't it? Now, observing all these terms, easily we are able to conclude what will the value of nth order derivative. आपको थोड़ा सा ये अरेंजमेंट करने के लिए थोड़े से एफर्ट्स लेने पड़ेंगे, थोड़ी प्रैक्टिस ज़्यादा लगेंगी यहाँ पे. 5-6 रिविजन, एटलीस्ट 5-6 रिविजन्स आर रिक्वायर्ड. सो आफ्टर दैट you easily are able to arrange these terms. Okay. So now here power of minus 1 is 1, in second order derivative power of minus 1 is 2, in third order derivative power of minus 1 is 3, means we can say that in nth order derivative power of minus n will be 1. In case of first order derivative we are getting 1 factorial, in the second order 2 factorial, in the third order 3 factorial, means in the nth order we will get here n factorial. In the first order derivative, what is power of 3? 1. In the second order derivative, power of 3 is 2. In the third order derivative, power of 3 is 3. So we can say that in nth order derivative, power of 3 will be n. And lastly, observe the power of what? 3x minus 5. Here power is 1 plus 1 in first order derivative, in second order derivative 2 plus 1, in third order derivative 3 plus 1, means we can say that here power in nth order derivative will be n plus 1. In this way, we have got our required value nth order derivative. Now see the example number 11th. To find out differentiation, it is very easy, but we have to do some adjustment here to find out nth order derivative, or we can say that according to nth order derivative. So here first easily we are able to find out first order derivative applying what? Product rule. So let us see first what result we are getting, means what first order derivative we will get, and later on we will see what adjustment we have to do here. Okay, so here we are differentiating it with respect to x, and function is in the form of u into v, means to find out differentiation, apply product rule. According to product rule, first term as it is into derivative of second term. What is second term here? Cos bx plus c, plus second term as it is, means cos bx plus c as it is, into derivative of first term. Derivative of first term is derivative of e raised to power x, isn't it? So which is equal to, here e raised to power ax, keep it as it is. Now we are finding its differentiation. It is in the form of cos f of x. What is derivative of cos f of x? Will be minus sin f of x. What is the value of f of x? That is bx plus c, into derivative of f of x, means derivative of bx plus c. Just simply we are applying standard formulas to find out differentiation. Here keep this term as it is, cos of bx plus c as it is. Now we are finding derivative of e raised to power ax. So its derivative is e raised to power ax into derivative of ax, because function is in the form of e raised to power f of x. So its derivative is e raised to power f of x into derivative of f of x, which is equal to e raised to power ax, keep it as it is. Here we can easily observe that differentiation of this whole term is b. So minus sin bx plus c, keep it as it is, into derivative of this term is b, plus cos bx plus c as it is, e raised to power ax also as it is, and derivative of ax will be equal to a. So differentiation is completed. Now we can observe that from both the term, we are able to take e raised to power ax, e raised to power ax common. If we are taking e raised to power ax common from both the term, so here remaining term is, better first write down positive term. If I am taking e raised to power ax common, here its multiple is a into cos bx plus c. Okay, and here minus b into, means here we are getting minus b into sin bx plus c. Just simply we have taken here e raised to power ax common from this first term. This is its multiple, means this will be the remaining term. Just simply we have first written positive term, later on we have written negative term. Again we are able to differentiate it, but since we have to find out nth order derivative, so we are trying to arrange it in some standard form so that easily we are able to get our value of nth order derivative. So here I am multiplying by under root a square plus b square, and since I am multiplying by under root a square plus b square, that's why I am dividing by under root a square plus b square. So here we will get a upon under root a square plus b square into cos bx plus c minus b upon under root a square plus b square into sine bx plus c. Already such method we have seen in case of trigonometric equation in the first paper of trigonometric function, that if the equation is in the form of a cos x plus b sin x or a cos x minus b sin x, at that time divide by under root a square plus b square to simplify it, isn't it? So here also value of a is a and value of b is b, so simply divide by under root a square plus b square, and that's why I am multiplying by under root a square plus b square, so which is equal to, or here substitute. Now as I stand, example is in terms of cos, so I am trying to arrange this term in terms of cos. We have two choices, we are able to arrange this term in terms of cos also, in terms of sin also, but example is in terms of cos, that's why I am giving priority to convert it in terms of cos. And what is the formula of cos? Cos A into cos B minus sin A into sin B, which is the formula of cos A plus B. So here cos A into cos B means to arrange it in the form of cos, we have to denote this term by cos. So put cos alpha is equals to, or a upon under root a square plus b square is equal to cos alpha, and substitute here sin b upon under root a square plus b square by sin alpha. So which implies that if we are taking division, so sin divided by cos will become what? Tan. So tan alpha will be equals to, since we have taken the division of right hand side, so take the division of this left hand side also. If we are taking division, under root a square plus b square will get cancelled and we will get b upon a. So b upon a, which implies that alpha is equal to tan inverse of b upon a, tan inverse of b upon a. In this way we have got the value of alpha also, and here we can observe that value of alpha is constant, whose value is equal to tan inverse of b upon a. Well, so if we are substituting all these values, so see what result we will get here. So e raised to power ax, keep it as it is. Again this term, as we have decided, we are replacing it by cos alpha into cos bx plus c, keep it as it is, minus also as it is. This term we are replacing by sin alpha into sin bx plus c. Okay, so which is equal to, now here under root a square plus b square, can I replace it by a square plus b square raised to power 1 by 2? Yes, square root can be written as raised to power 1 by 2 into e raised to power ax also as it is. Now we can observe that this expression is in the form of, consider this as a cos A into cos B minus sin A into sin B. Cos A into cos B minus sin A into sin B is nothing but value of what? Cos A plus B. A is bx plus c, and here b is what? Alpha. Means here which formula we have applied? Cos A into cos B minus sin A into sin B will be equal to cos A. A means bx plus c and b means what? Alpha. In this way we have got the value of dy by dx. Once the value of dy by dx is known to us, we are differentiating it to find out second order derivative. Now derivative of this dy by dx will be d2y upon dx square, d2y upon dx square. And to find out differentiation of this term, here we have to apply product rule u into v. So keep this first term as it is, means a square plus b square raised to power 1 by 2 as it is. Now according to product rule, keep this first term as it is. Now we are finding its differentiation. E raised to power ax as it is into derivative of second term, which is in the form of cos f of x. So its derivative will be equal to minus sin f of x. F of x is what here? Bx plus c plus alpha. Okay, so derivative of cos f of x is minus sin f of x into derivative of this f of x. Derivative of f of x means derivative of bx plus c plus alpha. Okay, now first term as it is, derivative of second term plus second term as it is. Second term means what here? Cos of bx plus c plus alpha as it is into derivative of first term. Into derivative of first term means derivative of e raised to power x is e raised to power x into derivative of x. Just simply we have applied product rule to find out this differentiation. So which is equals to, now here a square plus b square raised to power 1 by 2, keep it as it is, a square plus b square raised to power 1 by 2. Easily we can observe that from both the term we are able to take e raised to power ax common. If I am taking e raised to power ax common from both the term, here its coefficient is, what is the derivative of x? A into cos of bx plus c plus alpha. First I am writing positive term. Here we have taken e raised to power x common, so here its coefficient is this and derivative of this means b. B is the derivative of this whole term. B into minus means minus b sin bx plus c plus alpha. Okay, just थोड़ा सा मैंने शॉर्ट कर दिया है यहाँ पे. डिफरेंशिएशन फाइंड करने के बाद हमने e raised to power x कॉमन निकालना चाहिए था, लेकिन डायरेक्टली ऑलरेडी एग्जांपल बहुत बड़ा हो गया इसलिए थोड़ा यहाँ पे डायरेक्ट स्टेप ले लिए. सो विच इज इक्वल टू नाउ a square plus b square raised to power 1 by 2, keep it as it is. Again here e raised to power ax also as it is. Again to simplify it we are using same method. Again divide here by under root a square plus b square, and that's why multiply by under root a square plus what? B square. So here we will get a upon under root a square plus b square into cos of bx plus c plus alpha. Again here we will get minus b upon under root a square plus b square sin of bx plus c plus alpha. Just simply I am dividing to both the term by under root a square plus b square. So which is equal to, what is its product? This is also under root a square plus b square raised to power 1 by 2 means what? Under root a square plus b square. Under root a square plus b square into under root a square plus b square will be a square plus b square into, now keep this e raised to power ax as it is. I am replacing a upon under root a square plus b square by sin alpha. I am replacing it by sin alpha into cos of bx plus c plus alpha, keep it as it is, minus I am replacing it by sin alpha. Just to convert this expression in the terms of what? In the terms of formula of this term I am denoting by cos alpha. Now it is in the form of cos a into cos b minus sin a into sin b, which is nothing but value of cos a plus b. Example is in terms of cos, that's why I am trying to convert this expression in terms of cos. We have two choices, maybe it may be converted in terms of sin or it may be converted in terms of cos. तो हमने अभी cos में convert करने की कोशिश की, और अभी आपको ये भी लगाऊंगा कि ये term को हम cos क्यों denote कर सकते हैं और इसे क्यों sin denote कर सकते हैं. Because sum of square of these two numbers, sum of square of these two number is 1, and we know that sin square plus cos square is also 1, means sum of square of sin and cos is also 1, and sum of square of these two number is also 1. You can easily check that, find out square of this number, find out square of this number and take their addition, you will get definitely 1. तो हम ये जो numbers हैं ये identity satisfy कर रहे हैं. कौन सी identity? That sin square theta plus cos square theta is 1. That's why one of the number, if I am denoting by sin, denote another by cos, or if I am denoting first by cos, second can be denoted by sin, because this satisfies the identity that cos square theta plus sin square theta is equal to 1. So which is equal to, now here a square plus b square, keep it as it is, e raised to power ax also as it is. Now it is in the form of cos a into cos b minus sin a into sin b, which is the formula of cos a plus b. A is bx plus c plus alpha plus b. B is what here? Alpha, isn't it? So which is equal to a square plus b square e raised to power ax as it is into cos of bx plus c, alpha plus alpha will be 2 alpha. In this way we have got the value of second order derivative d2y upon dx square. Observing this, we will now trying to find out value of nth order derivative. Okay, so directly we are able to, by observing the first order and second order, we are trying to find out value of nth order. What is the power of a square plus b square in this expression? Will be 1 by 2, isn't it? 1 by 2, and here power is 1. Can I write it as 2 by 2? Okay, so here in first order derivative, power of a square plus b square is 1 by 2. In second order derivative, 2 by 2, means in nth order derivative, can I say that this power will be 3 by 2? First order में 1 by 2 है, second order derivative में 2 by 2 है, तो third order derivative में 3 by 2 होगा. 1 by 2, 2 by 2, 3 by 2, तो nth order derivative में हमें क्या मिलेगा हमें n by 2. Again observe here, power in first order derivative power is what? 1 by 2. Second order में 2 by 2, थर्ड ऑर्डर में 3 by 2 मिलेगा और nth ऑर्डर डेरिवेटिव में n by 2 मिलेगा. Keep this term is common in every case, e raised to power x into cos of bx plus c, also common here also bx plus c, and here also we are getting bx plus c. But here what is the coefficient of alpha? 1. In case of first order derivative, coefficient of alpha is 1. In case of second order derivative, coefficient of alpha is 2. Means in case of nth order derivative, coefficient of alpha is 3. In this way we have got the value of nth order derivative. Now see the last example from this question number 4 and from this exercise also. In this case also the function is in the form of y is equal to u into v. This example is very similar to the last example, means example number 11. Same method we are applying here, just a is replaced by 8 and b is replaced by what? 6. So we are differentiating it with respect to x. So to find out the derivative of this right hand side, we have to apply product rule. According to product rule, first term as it is, derivative of second term means derivative of cos of 6x plus 7 plus second term as it is, means cos of 6x plus 7 as it is, into derivative of first term, and here we can observe that first term is e raised to power 8x. Okay, so let us simplify again. So e raised to power 8x, keep it as it is in the form of cos f of x. What is derivative of cos f of x? Will be equal to minus sin f of x. F of x is 6x plus 7 into derivative of this f of x, means into derivative of 6x plus 7. Again here plus cos of 6x plus 7 as it is, derivative of e raised to power f of x is e raised to power f of x into derivative of f of x, means derivative of 8x. Okay, so which is equals to, now here first write down minus into plus will be equal to minus e raised to power 8x into sine of 6x plus 7, and derivative of this term will be equal to 6 plus cos of 6x plus 7 as it is into e raised to power 8x also as it is, and derivative of 8x will be equals to 8. Now derivative means differentiation is completed. Now let us simplify it. Here easily we can observe that e raised to power 8x can be taken common from both the term. E raised to power 8x we have taken common. First we are writing this positive term, later on write down this negative term. What is the multiple of e raised to power 8x? 8 into cos of 6x plus 7, and here minus 6 into sine of 6x plus 7, isn't it? Again I am trying to simplify it. Here what is the value of a is equal to 8 and b is equal to what? 6. A is equals to 8, so and b is equal to 6. So here under root a square plus b square, we are trying to find out value of under root a square plus b square. A means 8 square and b means what? 6 square. Easily we can observe that a square of 8 is 64 and square of 8 is 64 and square of 6 is 36. A 64 plus 36 is 100 and square root of 100 will be equals to what? 10. Means value of under root a square plus b square is 10. So I am multiplying by 10 here. Since I am multiplying by 10, so we are dividing by 10. So here we will get 8 by 10 cos of 6x plus 7, keep it as it is, 6x plus 7, again I am dividing by 10, so 10 sine of 6x plus 7, isn't it? Just simply I am dividing both sides by 10. 10 means by under root a square plus b square. If we are using this method at that time, definitely sum of square of these two number, a sum of square of these two number is always equal to 1, means these two numbers satisfies which identity? Cos square theta plus sin square theta is equal to 1, because their right hand side is also 1. So we are able to denote any one of these two number by cos. If one first number is denoted by cos, second denoted by sin, or first denoted by sin, second denoted by cos. लेकिन अभी हमारा example cos में है, so we are trying to convert it in terms of cos, and to convert it in terms of cos we have to denote the first number by cos alpha. So put 8 upon 10 is equal to cos alpha, and 6 upon 10 is equal to sin alpha, which implies that if we are taking division, sin upon cos will be equals to what? Tan alpha. And on this side division, if we are taking division, 10 will get cancelled, 6 upon 8 will be equals to 3 by 4, which implies that alpha is equal to tan inverse of 3 by 4. Last example में हमें tan inverse alpha की value क्या मिली थी? Tan inverse of b by a, but I have forget to substitute that value of alpha in the final answer. Okay, but here we will substitute the value of alpha. Try to make the correction in the last example. Final answer में last में हमारा आंसर कुछ तो भी ऐसा आया था, cos of I think there a bx plus c plus n alpha आया था. Just replace that alpha in the last example by tan inverse of b by a. Here value of alpha is tan inverse of 3 by 4. Try to understand it. If we are substituting all these values, see what we'll get. E raised to power 8x, keep it as it is, into 10 also as it is. Now I am replacing this first number by cos alpha, as we have denoted it by cos alpha, into cos of 6x plus 7 as it is, and minus 6 by 10. 6 by 10 I am replacing by sin alpha, into sine of 6x plus alpha, keep it as it is. So which is equals to e raised to power 8x, keep it as it is, into 10 also as it is. Now this expression is in the form of cos a into cos b minus sin a into sin b, which is nothing but value of cos a plus b. Let us suppose that a means 6x plus 7 and b means what here? Alpha. In this way we have got the value of first order derivative. Let us denote it by equation number first, means value of dy by dx. Now again differentiating it, we will try to find out value of d2y upon dx square, means second order derivative. Now again we are differentiating it. Derivative of dy by dx will be equals to d2y upon dx square. On this side e raised to power 8x, keep it as it is. Better we first write down 10. First write down 10 e raised to power 8x. We are finding differentiation, so we have to apply product rule. This is one term and this is second term. 10 is a constant term, keep it as it is. To find out the differentiation, we are applying product rule, means first term as it is, e raised to power 8x as it is, into derivative of second term. So I am directly finding derivative here. It is in the form of cos f of x. What is derivative of cos f of x? Will be minus sin f of x. What is the value of f of x? That is 6x plus 7 plus alpha, into derivative of f of x, into derivative of f of x, means derivative of 6x plus 7 plus alpha. Okay, so first term as it is, derivative of second term, plus second term as it is. Second term as it is means cos of 6x plus 7 plus alpha as it is, into derivative of first term. What is first term? E raised to power 8x, e raised to power 8x, isn't it? So in this way we have substituted the values in the product rule. So which is equals to 10, keep it as it is. So here e raised to minus into e raised to power 8x is minus e raised to power 8x sine of 6x plus 7 plus alpha as it is. Differentiation of this whole term is 6 plus cos of 6x plus 7 plus alpha as it is. Now derivative of e raised to power f of x is e raised to power f of x is 8x, into derivative of 8x will be equals to 8. Means differentiation is now completed. Again we are taking here e raised to power 8x common, e raised to power 8x common. First write down positive term. What is, if we are taking e raised to power 8x common, so here 8 into cos of So means what we are getting, 8 into cos of 6x plus 7 plus alpha. This is the coefficient of e raised to power 8x in the second term. But why we are writing that second term first? Because I am giving priority to write down first positive term and later on what, negative term. चलो यहाँ पे negative term substitute कर दो. So what, minus 6. First write down numerical value, then write down trigonometric function sine of 6x plus 7 plus alpha. Okay, so again we are using same method which you have applied in the last in the first case, that square of 8 and 6, sum of square of 8 and 6 will be equals to what, 100, and square root of 100 will be equal to 10. So I'm again multiplying by 10. So I'm multiplying by 10 means here we'll get 10 square, and since I'm multiplying by 10, that's why I'm dividing by 10 here. So 8 upon 10 into cos of 6x plus 7 plus alpha minus 6 upon 10 sine of 6x plus 7 plus alpha. Just simply we are multiplying and dividing by 10. Divide by 10, that's why multiply by 10. If I'm multiplying by 10, here we will get 10 square. So which is equal to, keep this 10 square as it is into e raised to power 8x also as it is. Already in the first part we have seen that denote this number by, first number by what? The first number denoted by cos alpha and second number denoted by sin alpha, so that this expression will get converted in terms of cos. So I'm denoting it by cos alpha. Already in the first part we have denoted it by cos alpha, so that's why again we are not writing the same thing here. And here this second number I am denoting by sin alpha into sine of 6x plus 7 plus alpha as it is. Okay, so now we can observe that this expression is in the form of, cos A into cos B, consider this as a cos A into cos B plus minus sin A into sin B, and cos A into cos B minus sin A into sin B is the value of cos A. A means what? 6x plus 7 plus alpha plus B. B is what here? Alpha. Okay, so cos A into cos B minus sin A into sin B is the value of cos A plus B. This is A and B is what? Alpha. So which is equal to 10 square, keep it as it is, into e raised to power 8x also as it is, into cos of 6x plus 7, alpha plus alpha will be equals to twice alpha. In this way we have got the value of d2y upon dx square. This implies that the nth order derivative means dny upon dx raised to power n will be equals to. Now observe the first term here. What is the power of 10 in the first order derivative? 1. In the second order derivative, power of 10 is 2, means we can conclude that in the nth order derivative power of 10 will be n. And this term e raised to power 8x appears in every term, so it can be written as keep it as it is, e raised to power 8x. In case of first order derivative, here we can observe that coefficient of alpha is 1. In second order derivative, coefficient of alpha is 2, means we can conclude that in nth order derivative coefficient of alpha will be n, isn't it? Lastly, let us substitute the value of alpha is equal to tan inverse of 3 by 4. In last example, means 11th example, I have not replaced alpha by its value. You have to replace that value of alpha. In that example, value of alpha is tan inverse of b by. So make that much correction. So here, which is equal to 10 raised to power n into e raised to power x into cos of 6x plus 7, cos of 6x plus 7 plus n alpha plus n alpha. I am replacing by, just a minute, cos of 6x plus 7 plus n alpha. Alpha I am replacing by its value, tan inverse of 3 by 4. In this way we have got the value of nth order derivative. So we have completed all the examples from this question number 4 of exercise 1.5. If you think that these videos are helpful to you, so please like the videos and share these videos with your friends also. In the next video, we will discuss the multiple choice questions from miscellaneous exercise.